Welcome to Data Tsunami, a podcast from Atempo. On today's episode, data management and protection challenges in HPC environments. Atempo VP of Sales and Alliances, Ferhat Kaddour, will be joined by Professor Mark Wilkinson, Director of the Dirac HPC facility. Dirac, Distributed Research Utilizing Advanced Computing, is the integrated supercomputing facility for theoretical modeling and HPC-based research in particle physics, astronomy and cosmology, and nuclear physics.
With supercomputing 2022 right about to happen in a couple of months in the US, we thought that it would be a great idea to have a conversation towards data management and data protection challenges and answers towards HPC environments. So again, Mark, thank you very much for joining us today.
It's a pleasure. Thank you very much for the invitation. Good to be here.
To start with, can you tell us a bit about the mission and the way that you are organized towards the Dirac organization?
Sure. So Dirac was set up in 2009, and we are the HPC provider, so the high performance computing provider for the UK theory community in cosmology, particle physics, nuclear physics, and astrophysics. And we've been going, as I said, since 2009. We've refreshed the hardware a number of times over that period, and we're a distributed facility, so our resources are located in 4 universities. So the University of Leicester, where I'm based, University of Cambridge, University of Edinburgh, and Durham University, and University College London is where the project office is hosted. And we're funded by a mix of funding. So our capital funding has typically come pretty much direct from government, so from BEIS in the UK, and we get our operations funding through STFC, the Science and Technology Facilities Council, and that's the body that funds all those areas of research that I mentioned. And our overall goal is to support the work of researchers in cosmology, nuclear physics, astrophysics, and particle physics. And in doing that, so all the work that we do in the different centres is to deliver that science. And so the computing services that we offer are designed around the specific workflows that they'll be supporting, and that's why we have multiple systems, is they have different architectures. So in total now we have, just to set it, the scale, we have 170,000 cores spread across the 4 sites, 500 GPUs, and somewhere between 10 and 20 petabytes of storage. And the way that we design our systems, we spend a lot of time ahead of any, well in advance of the procurement, to do a full study of the science program that we need to support. So that's done by the research community, writes down what they need to be able to do in the next 3 to 5 years. We get that externally peer reviewed, and once that's been approved, that's essentially our business case for why we need to have computing. We then have to look at how we translate that into a high-level technical case, which essentially says, here are the services, the kind of services we need, and the scale that they need to be in order to deliver that science. We get that externally reviewed as well, and at that point, we're in a position to start talking to industry and vendors to work out how we're actually going to build the systems and then do our tenders and all of that. So this very tight link between the science program and the services that we provide, the computing and storage services we provide, is key to the success of the facility. And so that's something that we repeat that cycle. We've done it multiple times over the last decade. And so we're always keen to work with partners such as Atempo to develop projects so that we can actually move that forward. So as well as supporting the science, we are also delivering innovation. And so our innovation program is very much tailored to projects which support the science program. But in doing that, we want to be working on projects where it's of interest to Atempo or other industry partners as well. So we put a lot of thought and work into making sure that we're working in areas where the reasons why we're interested in particular problems are usually not the same, but we can often find common problems that we both have an interest in solving. And the third aspect of our mission is training. And that's absolutely key these days, as all aspects of HPC and indeed of storage are changing in terms of what's available. And so we have to make sure that our users are highly skilled so that they can make the best use of the resources that we've got. And it's also one of our main contributions to the UK economy is the training program, which kind of upskills the students and early career researchers in our community. So that gives an overall sense of how Dirac functions.
So that's really interesting. So on one side, you have researchers, and on the other side, you have students that are developing their skills, knowledge, expertise on the systems. As a ballpark, can you give us an idea of the number of researchers that have access to your platform, and how many students by year you're taking for training?
So the total number of active users ranges between, in any given quarter, it's between 400 and 600 people will have submitted jobs on one or more of the systems. We've got a total of about 2,000 registered users, but not all of them are active at any given time. In terms of the number of students, we typically have about 100 PhD students going through taking our basic training in any given year. And the total number of students I'll have to look up.
Which in other words means that you have a system which is under heavy load.
Yes, so I think the key thing is, as well as saying we've between 400 and 600 people using it, we've over 100 projects that are actively using it, and the utilization of all the systems is typically 90% or higher. So we have very little spare capacity, and most of the systems, most of the time, they're as full as it's possible to be when the jobs that you're running are very large. So we're typically, we have jobs that go up to as many as 40,000 cores. And so when you're trying to schedule those kind of jobs, 100% utilization is difficult to get, but we're consistently above 90.
And on the panel of researchers with which you are working with, I mean, are these guys technical enough to not request your assistance on a 24/7 basis, or can you expect from them to be able actually to restore a project, archive a project, or do you really need to work as a managed facility for them?
So the honest answer is that varies. So it varies between projects. We've got some projects where there are a set of users who would be able to do all of that kind of management themselves. But in general, things like restoring something where there's been, like restoring from a backup, that's something that we would do, that our tech support teams would do on their behalf. One thing we'll probably come to later, but I can mention now, is we're keen to involve to make it easier for the researchers to be involved in things like decisions on which data should be kept and for how long it should be kept and where it should be kept. And so that's part of our interest in working with Atempo, was around how we get from, at the moment, we just have live data essentially on the on spinning disks and tape, which is not a fully managed data curation service at this point, but is essentially just somewhere else to put the data. And we want to move to a situation where the data that's on tape is easily accessible and can actually be curated so that we can keep it for the long term. That is not something that we as a facility can decide, though, because we're not the ones actually doing the simulations, and so the community has to also have the ability to say, right, this piece of data is valuable, this is the data that I want to be kept for the next 10 years, and this other piece of data isn't needed.
So, as you mentioned, I mean, we initiated a cooperation between Dirac and Atempo towards our flagship product, Miria, which is a data management solution able to offer you analytic capabilities on unstructured data, archive, backup, synchronization, as well as migration services. So you initially started with archive, knowing that Miria can either help you to fully automate archive workflows or offer you the ability to let actually the end users manage by themselves their archive workflow. Can you tell us a bit about how the adoption and maybe implementation has gone through at Dirac?
As you said, we're using it now in 2 sites. We've been using the Atempo products at the University of Durham, the memory intensive service, for longer. That was our first deployment. And so Alistair Basden, who's the technical manager there, he's been kind of leading the work with Atempo. And there were a number of reasons why Miria was a good choice for archiving from our perspective. And it included the fact that you can have duplicate archives on different tape libraries. You can have a choice between command line access and GUI access. That's important because not some users prefer one or the other. A lot of our users would prefer a command line. And then having different rules on how you parallelize, depending on the size of the archive, that also helps in terms of scheduling of things. The fact that there's a web browser interface as well, so that it integrates with the LDAP system, that was another key selling point for us. And so at the moment we're in the phase where the software is deployed and we're working with the user community to increase the adoption, because at this point we haven't, for example, made final decisions on the point that you mentioned about whether we want whether it should be fully automated or more user driven. If we get what we can't have is that our long-term storage becomes just another bucket that data gets tipped into. That's not what we want. So we actually, whatever process we have, the automation will stop at some point, and there'll be a point where a user has to at least raise a flag and say these data are valuable, and at that point we'll be asking for metadata to be added. And so we're going through the process now of piloting these and working out how can we help the users to provide the information that's needed for the longer term storage, and longer term curation of the data to make them valuable. And this is all driven, again, as I said at the beginning, we don't do things in Dirac just because we can or because somebody has told us we have to. The driver for this is we know how valuable the data from the simulations done on Dirac have been already. And a good example of that, and this is again why we're centering the work has started from Durham, is in 2005, the Virgo Consortium, who are based in Durham and large users of Dirac systems, and I say based at Durham, there's a large fraction of the consortium is there, but actually it's a big international consortium of researchers. They do large-scale cosmology simulations, and in 2005, when they did the Millennium simulation, they made the whole all the output data, all the snapshots of the simulation, they made them publicly available on the web so that people could just download them. Since that time, they've been downloaded many times, and more papers have been written by people who had nothing to do with the original simulations, but just have been able to use the data. And so that has kind of set the bar for what we need to be able to provide, is that it has to be easily accessible and findable and searchable by other users, and we need to be curating it for at least 15 years. So, and that is essentially our data curation service. That's one of the design points that we have to achieve. Actually, it's easier to keep it for 15 years than it is to fund it for 15 years. So the challenge is how we actually keep it going. The ability to curate it properly, add metadata easily, that's where the value is. So that community are already experienced in doing this. And the idea is, once we've worked with Myria enough to decide exactly how we want to use it, we can then do the same and encourage other communities to start putting their reference simulations and making them publicly available as well.
You're listening to the Data Tsunami podcast from Atempo, leading provider of data protection and data management solutions. For more information about our products and services, visit atempo.com. Hey, planning on coming to the SC22 Supercomputing Show this November in Dallas, Texas? So are we. Come visit Atempo at booth 4112.
Myria has quite an extensive compatibility guide when it comes to being able to get data from source storage to target storage. Can you remind us what you at Dirac are using as tier 1, tier 2, and maybe the evolution that you see for the future?
Yeah, so at the moment it's all Lustre. It's all the systems are Lustre-based, spinning disks. At Durham, we also have a large volume of flash, but that's in front of the spinning disks and that's for that's for checkpointing of the simulations as they're running. That's one of the key features of the Durham system, the memory-intensive service, and then behind that we have tape, but not on all our systems. So we have tape at Edinburgh and at Durham.
So in the world, I mean, you mentioned Lustre. I'm going to do a digression. In 2022, unfortunately, there is something which is terrible and happening everywhere, which is the level of cybersecurity threats that are all around. If a few years back, I mean, a lot of people were thinking that these hackers, I mean, professionals or not professionals, would only restrict their activity to these large private companies that have money to pay ransoms and so on. The reality, and we have again seen that with what happened to an organization in the US, is that even, let's say, gov-funded or organisms that are really working for the health of everyone are actually targets. What's the approach of Dirac towards security and the protection of your IT environment?
Yeah, so the approach we're taking is essentially to join forces with other providers in the UK. So we're in terms of sharing information about threats and responding to threats collectively. So we've worked over the past couple of years with IRIS. That's an STFC organization. It's kind of an umbrella for all the computing facilities within STFC, and they have put together various protocols for sharing information, and there's regular meetings to keep everyone informed about what's going on, because obviously the threat has increased over recent years. There's also, as UKRI, so that's the overall the agency kind of above the research councils that encompasses all the research funding in the UK from direct government research funding. That is, they're working on the development of a digital research infrastructure for the UK, essentially for UKRI. And again, they're developing the protocols for that, again with a view to essentially protecting as a group rather than each individual service being protected. Because it's a challenge, we're a distributed facility. Our users are not based at the sites where the computers are housed, so everybody's connecting remotely. So we've always had a security risk in the sense that if you have a user who's not physically beside the computer, you have a security risk. And even if you have one who is beside it, you still have to know who they are. And so we've funded work over the last year as well on identity management, and so that we'll have better ability to authenticate as we go to a system in the future, an ecosystem in the future, where we expect more movement of users between facilities. So at the moment we have our 4 Dirac services systems. Users can move between them, but they log in separately. So in the future we would expect people to be able to have kind of single sign-on for UKRI services in general, and then that particular account would be allowed to access particular services. But yeah, there's a lot of work to be done to make sure that's done securely. Obviously, I can't talk about in detail about the operational things we do to protect the systems, but it's something that we're very actively engaged in to make sure that they're as secure as possible. And you might imagine that Dirac, because the work we're doing is it's all government research funding. They're all based in universities. It's cosmology, particle physics. It's not it's not the kind of thing where if you hold us to ransom, we have a lot of money to pay a ransom. So you might imagine it's not a target, but unfortunately, that's not the case.
Unfortunately, as you say. So the cybersecurity is one thing. I mean, having an insurance against something bad happening is another thing. So you can call it cyber resiliency, as that these are the new words, or you can call it disaster recovery plan. There is a need for a plan like this to exist in an organization. A few years back, Lustre was essentially used as a scratch. The usage are changing, the volume of data is increasing, and we have seen a few years back more and more demands from different end users to have an efficient backup solution for Lustre. That's why at Atempo we developed a fast scan capability, which is, in a few words, allowing us to do an initial scan on the Lustre and then do incremental forever, allowing to implement a real backup, an efficient backup, I'm going to say, on Lustre. Is it something that you have already integrated into your plan, or is it something to come?
All I can say is that is definitely a feature that we were waiting for. Whether it's actually been rolled out in Durham, I'm fairly sure it has. But I know it was one of the key features we were looking for.
The nice thing is you need it, you have it. And again, it goes to the point that Myria is a multi-service solution in the sense that you can start with archive, then do backup, then implement a synchronization workflow between an S3 or a GPFS or Lustre. It's one ring to rule them all, as some people might say. So thank you for this honest answer. Going to the end of this podcast, I mean, can you tell us a bit about the evolution that you're seeing in your environment?
So I think the main evolution, that there's 2 key things on our roadmap in terms of data. One is the one I've already talked about, the data curation service. So being able to curate data properly for the long term. The other is federation between our services. So as I said, we've got deployments at 4 different sites, but the sites are at the moment they're still relatively independent in terms of connectivity. So what we are working now, we have a tempo being used at Edinburgh and in Durham. The next thing to try is looking at the essentially using Myriad to do the federation between the two sites. We have to establish exactly what that federation has to look like, but and I imagine we'll take various steps along that road. Eventually we'd like to be in a position where I could say, I have a job that I want to run. It requires these input data, which are stored, let's say, at Durham, and I need this kind of compute architecture. And an intelligent scheduler would look around the Dirac sites and say, okay, you can run at Durham, which is where the data are sitting, but you'll have to wait a week because it's already full. Whereas there's some suitable hardware on the Cambridge service, let's say, that's coming up tomorrow, and there's just enough time for me to move the data from Durham to Cambridge. So then the scheduler would make sure the data is staged at another site ready to go. Now, the other thing we obviously nowadays have to factor in as well is what's the carbon footprint of those two options. So that would be something we'd also build in, because we shouldn't be moving data around. That's not free. And so we shouldn't be moving data around for no reason. But if it's increasing utilization, and in some cases it will be the case, because we did upgrade our network link between Durham and Cambridge, because there are workflows where generating the data is done on one of our architectures, but the analysis is better done on another. And so we expect, given the heterogeneity of computing, the increased heterogeneity in that everybody's seeing, and the fact that workflows are therefore going to be making use of different architectures, there's going to be an amount of data movement that's required to make the best use of that. And so inevitably there's going to be a need to have not just Dirac federated, but also UKRI data federated in a way that it can be easily moved around. So I think that's we're taking steps towards that with our kind of planning for the data curation service, but that will take some time because it's a challenging problem.
And we are looking forward to help you and support you in putting these new workflows alive. I started saying that SC 2022 is around the corner. What are your expectations this year?
One obvious thing is the fact it's back to face-to-face. So it's in person again. That will be great, because we have, certainly within Dirac over the last year, we've very much seen the benefits of face-to-face meetings. So we always knew that, but there's no substitute for being able to sit down and talk and throw ideas around. That's very valuable, and we certainly missed that the last few years. So that in itself is something we're looking forward to. Obviously, I'm expecting to see more news about exascale from various places, more results coming off, early results coming off systems. I think I'd expect a lot about sustainability. And again, this actually comes into the data question as well. There's often data has been, simulation data has been treated not carelessly, but as if it would, you don't have to worry too much about it because you can always create it again, in contrast to data from an experiment where you can't, or from a telescope. However, there's a carbon footprint associated with generating. If you run a simulation for 3 months on a supercomputer, that's generated a carbon footprint. Best thing, what you should be doing is using those outputs for as long as possible and not have to recreate them. And so there's definitely more thought going into that side of things. So keeping the data because the data has an embedded carbon footprint as well as whatever its scientific value is. So throwing data away and then just saying, well, I'll generate it again in 2 years' time is not, it is something that needs more thought now than it did perhaps 5 years ago. So I'm expecting there'll be a lot more discussion of net zero and sustainability related things. I think also the whole life cycle cost in terms of carbon of computing is something that's becoming increasingly important, and it's right that it should. I think my view is that we can't get rid of the carbon footprint of computing, because the hardware, there's hardware costs, there's footprints, so there's embedded costs, embedded footprints we can't get rid of, but we should be minimizing them, obviously, getting the most out of everything in terms of hardware, and that has implication for software as well. And then making the case for why supercomputing and computing in general is valuable. So there are plenty of things that will always have a carbon footprint. So it's perfectly right that we should be asked to justify what we're doing. But I think that's the point we're going to get to, where we make it as low a footprint as we can. And then we say, okay, this is how much of a footprint is generated by this work. Is that okay? And society will tell us yes or no.
Protecting the world by making the world better. That's quite a plan, and a nice thing to achieve. Mark, I am really looking to see you at the SC 2022. Thank you very much for your time today. I hope the audience will appreciate the podcast. And again, looking forward to see you over there.
Yeah, pleasure. Thank you for the opportunity to talk to you as well. And yeah, looking forward to seeing you in Dallas.
Good day, everyone. Thank you.
You've been listening to the Data Tsunami podcast from Atempo. Atempo is a global leader in data protection and data management software solutions. With headquarters in Paris, France, Atempo has offices in EMEA, APAC, and the Americas, and thousands of worldwide customers and partners. Visit atempo.com for more information about the company, products, and services. And visit our resources section, where you can download a copy of case study Dirac and find out how Atempo solved their archiving challenges.